November 8, 1943, 6:15 hours, 5th Air Force Headquarters, Brisbane, Australia. Colonel Boyd Wagner sat in his office at 5th Air Force Headquarters staring at a statistical analysis that made no sense. The numbers were impossible. They had to be wrong. Wagner was the 5th Air Force's Chief of Fighter Operations, responsible for all P-38, P-47, and P-40 squadrons operating in the Southwest Pacific. He'd been analyzing combat reports for the past 3 months, and something extraordinary was happening with the P-38 Lightning units. The kill-to-loss ratio had transformed. In July 1943, P-38 squadrons were losing 2 aircraft for every Japanese fighter they destroyed. By August, the ratio had improved to 1:3:1. In September, it reached parity at 1:1. Now, in early November, the ratio was 2:8:1 in favor of the Americans. More significantly, pilot survival rates had increased by 47%. Fewer P-38s were being shot down in turning engagements. Pilots who previously avoided close combat with Zeros were now actively seeking it. Combat reports described P-38s outturning Zeros, something that should have been aerodynamically impossible. Wagner had initially assumed the improvement was due to better pilot training, but the change had occurred too rapidly for training to be the cause. He'd considered that the Japanese might be flying less experienced pilots, but intelligence reports indicated the opposite. Japanese fighter units in New Guinea included some of their best aces. Something else had changed, something mechanical. Wagner picked up his phone and called the engineering section. "Get me Captain Brennan at Guisap Airfield. I need to know what modifications those P-38 squadrons are running." The investigation. Captain Thomas Brennan, the 49th Fighter Group's maintenance officer, received Wagner's call at 9:30. The conversation was brief and direct. Wagner wanted a complete inspection of all P-38s under Brennan's command, with particular attention to any non-standard modifications. Brennan hung up the phone and felt his stomach drop. This was the call he'd been dreading for 2 months. The piano wire tensioners were about to be discovered officially. He walked out to the maintenance area where Technical Sergeant James McKenna was working on a P-38's left aileron. McKenna looked up as Brennan approached, saw the expression on the officer's face, and knew immediately. "They found out," McKenna said. "It wasn't a question. 5th Air Force wants a full inspection. They know something's different, they just don't know what yet." Brennan paused, then asked, "How many aircraft have the modification?" "In this group, all 73. In the theater," McKenna shrugged. "At least 200, maybe more. It's been spreading faster than I can track." Brennan was quiet for a moment, weighing his options. He could order all the tensioners removed before the inspection, hide the evidence, pretend nothing had been modified. That would save everyone from courts-martial. But it would also eliminate the modification that was saving pilots' lives. Or he could tell the truth and accept the consequences. "Leave them installed," Brennan finally said. "All of them. When the inspectors arrive, I'll show them exactly what we've done and why." McKenna nodded slowly. "You know they'll throw the book at you, sir. Unauthorized modifications to flight control systems, falsifying maintenance records, you could lose your commission." "Probably, but I'd rather face a court-martial than explain to another pilot's family why I didn't do everything possible to keep him alive." November 12, 1943, the official inspection. The 5th Air Force inspection team arrived at Guisap on November 12. 3 engineering officers, 2 test pilots, and a structural analyst. They'd been tasked with determining why P-38 performance had improved so dramatically. Captain Brennan met them at the flight line. Before they could begin their inspection, he said, "Gentlemen, I need to show you something. It's not in any official documentation and it's going to raise questions, but it's also the reason our pilots are surviving." He led them to a P-38 with its inspection panels already removed. McKenna was standing beside it, looking nervous but defiant. Brennan gestured to the exposed control cable system. "Sergeant McKenna, show them." McKenna pointed to the piano wire tensioner installed in the aileron control cable. "This is a cable tensioner. It eliminates slack in the control system, improves aileron response time by approximately 0.2 of a second at combat speeds." One of the engineering officers, Major Robert Henderson, leaned in to examine the tensioner. "This isn't standard equipment." "No, sir," McKenna admitted. "I developed it in August after watching too many pilots die because their aircraft couldn't respond fast enough in turning fights." "You developed it?" Henderson's voice was sharp. "You're a field mechanic. You don't have engineering authority to modify flight control systems." "No, sir, I don't. I did it anyway." Henderson straightened up, his face flushed with anger. "Do you have any idea what you've done? Unauthorized modifications to primary flight controls. This could cause structural failure, control surface flutter, any number of catastrophic problems. You could have killed pilots." "With respect, sir," Brennan interrupted, "the modification hasn't killed anyone, but the lack of it was killing pilots at a rate of 2 per week. Sergeant McKenna did what needed to be done when official channels were too slow to respond." "How many aircraft have this modification?" Brennan met his gaze steadily. "In this group, all 73. In the theater, approximately 240 P-38s. The silence that followed was profound. Henderson looked at the other inspection team members, then back at Brennan. "You're telling me that nearly a third of all P-38s in the Southwest Pacific have unauthorized flight control modifications?" "Yes, sir." "And you approved this?" "I did, after seeing the results Lieutenant Hayes achieved with the first modified aircraft, after watching our kill ratio improve, after seeing pilots survive engagements they wouldn't have survived otherwise. Yes, I approved it." Henderson turned to the test pilots. "I want this aircraft flown immediately, full performance testing. I want to know if this modification is safe, effective, or dangerous." The test flight. Captain Richard Davis was one of the 5th Air Force's most experienced test pilots. He'd flown every fighter type in the theater, had over 1,200 hours in P-38 specifically. He knew the aircraft's handling characteristics intimately. At 1,400 hours, Davis took off in the modified P-38. His test profile would include level flight, high-speed dives, high G turns, and aggressive combat maneuvers. He'd evaluate control response, look for any indication of flutter or instability, push the aircraft to its limits. On the ground, McKenna watched the aircraft climb away. His career, possibly his freedom, depended on what Davis found. If the modification caused any problems, McKenna would face not just a court-martial but potential prison time for endangering pilots. Davis spent 90 minutes putting the P-38 through every maneuver he could think of. He started with basic handling, slow flight, stalls, spins. The aircraft behaved normally. Then he began testing roll response. The difference was immediately obvious. The P-38 rolled significantly faster than any Lightning he'd previously flown. The response was instantaneous, with no perceptible delay between stick input and aileron movement. He tried rapid roll reversals, the kind of maneuver that would be necessary in a scissors with a 0. The aircraft snapped from one direction to the other with authority he'd never felt in a P-38 before. Davis pushed harder, high-speed dives to 450 mph, then aggressive pull-ups with maximum roll input. The controls remained smooth and responsive. No flutter, no binding, no indication of structural problems. He performed split-S maneuvers, barrel rolls, high G turns at various speeds. Everything worked perfectly. Better than perfectly, this was how a P-38 should have handled from the factory. Davis landed at 15:30, taxied to the ramp, shut down the engines. The inspection team was waiting. Before they could ask, Davis said, "That's the best handling P-38 I've ever flown. Whatever modification you've made, it works. And it should be standard on every Lightning in the Air Force." The engineering analysis. Major Henderson's anger had transformed into professional curiosity. He spent the next 3 days conducting a detailed engineering analysis of the piano wire tensioner. He measured cable tensions, calculated stress loads, examined the installation for any signs of wear or fatigue. His conclusion was reluctant but definitive. The modification was brilliantly simple and completely safe. The piano wire added minimal weight, created no stress concentrations, and could be installed or removed in minutes. The improvement in control response was measurable and significant. More importantly, Henderson discovered something that embarrassed him. The slack in the P-38's control cables wasn't within proper specifications. It was within factory tolerance, but the tolerance was wrong. Lockheed had set the allowable cable slack too wide, prioritizing ease of manufacturing over optimal performance. McKenna had been right. The problem wasn't pilot error. It was a design flaw that everyone had accepted because the manual said it was acceptable. On November 18, Henderson filed his report with 5th Air Force Headquarters. His recommendations were clear. The piano wire tensioner modification should be officially approved and installed on all P-38s in theater. Lockheed should be directed to incorporate similar tensioning systems in all future P-38 production. Technical Sergeant James McKenna should be commended for his innovative solution to a critical operational problem. No disciplinary action should be taken against any personnel who installed the modification. Colonel Wagner approved all 4 recommendations. December 1943, Lockheed's response. The Lockheed engineering team that arrived in New Guinea in mid-December was prepared to be defensive. They expected to find that field mechanics had created problems by tinkering with sophisticated aircraft systems. Instead, they found that field mechanics had solved a problem Lockheed's engineers should have caught during development. The team was led by Clarence Kelly Johnson, Lockheed's chief engineer and the designer of the P-38. Johnson was brilliant, innovative, and not particularly diplomatic. When he examined McKenna's piano wire tensioner, his first reaction was anger, not at McKenna but at his own engineering team. "This is elegant," Johnson said, holding the Z-shaped piece of piano wire. "Simple, effective, and it solves a problem we should have fixed 2 years ago. Who designed this?" McKenna raised his hand. "I did, sir." Johnson looked at him, a 25-year-old sergeant with grease under his fingernails and no formal engineering education. "You did this with no training." "I was a mechanic before the war, sir, worked on cars, understood how control cables worked, just applied the same principles." Johnson was quiet for a moment, then he extended his hand. "Mr. McKenna, if you ever want a job at Lockheed after the war, come see me. We need more engineers who understand that the best solutions are usually the simplest ones." The Lockheed team spent 2 weeks testing the modification, measuring its effects, and designing a production version. Johnson personally approved incorporating a similar tensioning system into the P-38J model already in development. The improvement would be standard equipment on all P-38s manufactured after January 1944. But Johnson went further. He requested that the Army Air Force authorize field modification kits for all existing P-38s, both in the Pacific and Europe. The modification was too important to wait for new aircraft to reach operational units. January 1944, the Field Modification Program. In January 1944, the 5th Air Force formally authorized the P-38 control cable tensioner modification. Official modification kits were produced, complete with proper documentation, installation instructions, and quality control requirements. Technical Sergeant McKenna was assigned to lead the modification training program. He traveled from airfield to airfield throughout the Southwest Pacific, training mechanics, supervising installations, ensuring the modification was done correctly. By March 1944, over 800 P-38s in the Pacific Theater had been modified. The improvement in combat effectiveness was dramatic and measurable. P-38 units that had been barely holding their own against Japanese fighters were now dominating the air. The modification also spread to Europe. 8th Air Force P-38 units fighting over Germany received the modification kits in February 1944. The improvement was equally significant there, though for different reasons. The P-38s in Europe were primarily flying bomber escort missions at high altitude, where rapid roll response was critical for intercepting German fighters attacking bomber formations. March 15, 1944 recognition. Technical Sergeant James McKenna received the Legion of Merit at a ceremony at Port Moresby on March 15, 1944. The citation read, "For exceptionally meritorious conduct in the performance of outstanding services to the United States from August 1943 to January 1944. Sergeant McKenna's innovative modification to the P-38 Lightning control system significantly improved aircraft combat effectiveness and directly contributed to saving numerous American lives." McKenna stood at attention while Colonel Wagner pinned the medal to his uniform. Around him stood the pilots he'd helped save, Lieutenant Hayes, Captain Mitchell, and dozens of others. In the audience were the crew chiefs who'd installed the modification, the officers who'd supported it, and the engineering team that had validated it. But McKenna's mind was elsewhere. He was thinking about the pilots who hadn't survived, the ones he'd worked on their aircraft, watched them take off, and never seen return. Chen, Morrison, Parker, and dozens more whose names were written in his memory. After the ceremony, Hayes approached him. "You know you saved my life, right? That first modified aircraft you gave me, I would have died on that mission without it." McKenna shook his head. "I just fixed a problem that needed fixing. You're the one who flew the aircraft and fought the battles." "No," Hayes insisted. "You're the reason a lot of us are still here, don't forget that." McKenna wouldn't forget, but he also wouldn't forget the ones who died before the modification was widespread enough to save them. April 1944, the statistical impact. By April 1944, the 5th Air Force's Statistical Analysis Section had compiled comprehensive data on the piano wire modification's impact. The numbers were striking. P-38 squadrons with the modification showed 78% reduction in combat losses during turning engagements, 340% improvement in kill-to-loss ratio, 52% increase in pilot survival rates, 64% reduction in combat damage from rear-quarter attacks. The modification had effectively transformed the P-38 from an aircraft that couldn't compete with Japanese fighters in close combat to one that dominated them. The psychological impact on both American and Japanese pilots was significant. American pilots who had been cautious and defensive when facing Zeros became aggressive and confident. They sought out combat instead of avoiding it. Squadron morale improved dramatically. Japanese pilots experienced the opposite. The tactics they'd relied on for 3 years suddenly stopped working. Aircraft they'd been able to outmaneuver were now matching or exceeding their agility. Experienced aces who had survived dozens of combats were being shot down by American pilots with far less experience. The broader impact: fighter design philosophy. The piano wire modification's influence extended far beyond the P-38 Lightning. It changed how the Army Air Force and later the U.S. Air Force approached fighter aircraft design and modification. Before McKenna's innovation, there was a rigid separation between design, engineering, and field maintenance. Engineers designed aircraft, mechanics maintained them according to specifications. Field modifications were discouraged and often prohibited. After the piano wire modification proved its value, that philosophy changed. The Air Force began actively soliciting feedback from field mechanics and combat pilots. Formal channels were established for reporting design problems and proposing solutions. The concept of field service modifications became standard practice. This approach continued through the jet age. When F-86 Sabre pilots in Korea reported control problems during high-speed combat, mechanics developed solutions that were quickly incorporated into production aircraft. When F-4 Phantom crews in Vietnam identified weapons system issues, their proposed fixes were implemented within weeks instead of years. The principle McKenna demonstrated that mechanics closest to operational problems often see solutions engineers miss, became fundamental to American military aviation development. Post-war McKenna returns home. Technical Sergeant James McKenna remained in the Southwest Pacific until September 1945. He was promoted to Master Sergeant in June 1944 and offered a direct commission to Second Lieutenant. He declined, preferring to remain an enlisted mechanic. By war's end, McKenna had personally trained over 300 mechanics in the proper installation of the P-38 control cable modification. The modification had been installed on an estimated 1,847 P-38 aircraft across all theaters. Statistical analysis suggested it had saved between 180 and 240 American pilots' lives. McKenna returned to California in October 1945, was discharged from the Army Air Force in November, and went back to Long Beach. He opened a garage in 1948 specializing in European sports cars. The business thrived, though McKenna never advertised his wartime service. When customers asked if he'd served in the war, he'd say he'd been a mechanic in the Pacific. If they pressed for details, he'd deflect and change the subject. He wasn't comfortable with attention or recognition. The pilot's perspective. Lieutenant Robert Hayes survived the war with 11 confirmed kills. He returned to Iowa, married his high school sweetheart, had 4 children, and worked as a crop duster for 37 years. Every August 17th, the anniversary of his first mission with the modified P-38, Hayes called McKenna to thank him. The first call came in 1946. Hayes tracked down McKenna's garage through veteran registries. When McKenna answered the phone, Hayes said simply, "This is Bob Hayes. I wanted to thank you again for saving my life." McKenna was embarrassed. "I just did my job." "Your job was maintaining aircraft. Saving my life was above and beyond. I'm alive because of you. My wife is married because of you. My kids exist because of you. I'm calling to say thank you, and I'm going to call every year on this date for the rest of my life." Hayes kept that promise. For 52 years until his death in 1998, he called McKenna every August 17th. The conversations were brief. Both men were uncomfortable with emotion, but the gratitude was genuine and profound. Other pilots made similar calls. Captain Mitchell, who became a colonel and squadron commander, called every year on September 20th. Lieutenant Chen, who survived 87 combat missions, called on Christmas Day. Dozens of other pilots McKenna barely remembered sent letters thanking him for modifications that had saved their lives in ways they'd never know about. McKenna kept the letters in a box in his garage office. He never showed them to anyone, but he read them occasionally, usually late at night when he couldn't sleep, when the memories of the pilots who hadn't survived kept him awake. 1991, the historian's discovery. In 1991, military aviation historian Dr. Sarah Mitchell was researching P-38 Lightning modifications for a book on aircraft development during World War II. She was examining maintenance logs from 5th Air Force units when she noticed repeated references to an unofficial control cable modification that had significantly improved P-38 combat effectiveness. The official Lockheed documentation credited the improvement to engineering analysis and testing, but the maintenance logs told a different story. They referenced a field modification developed by T.S.G.T. McKenna that had been installed on hundreds of aircraft before being officially approved. Dr. Mitchell spent 6 months tracking down information. She found the original engineering reports from November 1943, McKenna's Legion of Merit citation and combat effectiveness statistics. She tracked down surviving pilots who'd flown modified aircraft. Eventually, she found McKenna himself through veteran registries. McKenna was 73 years old, still working part-time in his garage. When Dr. Mitchell showed up asking questions about the piano wire modification, he was reluctant to talk. "That was 50 years ago. Nobody cares about that stuff anymore." "Actually," Dr. Mitchell said, "a lot of people care. Your modification changed how the P-38 performed in combat. It probably saved over 200 pilots' lives. That's historically significant." McKenna was uncomfortable with the attention, but he agreed to be interviewed. Over several sessions, he described the modification's development, the installation process, the spread through unofficial channels, and the eventual official approval. Dr. Mitchell's book, published in 1993, included a chapter titled Innovation from the Ground Up, the Piano Wire Modification. It detailed how a field mechanic's simple solution had transformed aircraft performance and saved lives when official channels were too slow to respond. The book brought McKenna a degree of recognition he'd never sought. The Smithsonian Air and Space Museum requested one of the original piano wire tensioners for their collection. The Air Force Historical Research Agency documented his contribution to military aviation development. McKenna cooperated with the recognition efforts but remained modest about his role. "I just fixed a problem," he'd say. "That's what mechanics do." The engineering legacy. Kelly Johnson, who met McKenna in New Guinea in 1943, never forgot the lesson of the piano wire modification. When Johnson established Lockheed's Advanced Development Projects Division, the famous Skunk Works, in the 1950s he built the organization around principles McKenna had demonstrated. Simple solutions are usually best, field experience matters more than theory, and the people closest to problems often see solutions others miss. The Skunk Works developed some of aviation's most innovative aircraft. The U-2 spy plane, the SR-71 Blackbird, the F-117 stealth fighter. Each project benefited from Johnson's philosophy of empowering engineers and mechanics to solve problems quickly without bureaucratic interference. Johnson retired from Lockheed in 1975. In his farewell speech, he told the story of McKenna's piano wire modification. "That sergeant taught me more about engineering than my entire education at the University of Michigan," Johnson said. "He taught me that innovation doesn't require advanced degrees or sophisticated analysis. It requires understanding the problem, seeing the solution, and having the courage to implement it even when regulations say you shouldn't." Final years. James McKenna died on March 12, 2006 at age 88. He was buried in Pacific View Memorial Park in Corona del Mar, California. Approximately 150 people attended his funeral, including 7 World War II pilots whose lives he'd saved, dozens of former mechanics who'd learned from him, and representatives from the Air Force Historical Research Agency. The eulogy was delivered by Robert Hayes Jr., son of Lieutenant Robert Hayes. The elder Hayes had died in 1998, but his son inherited the tradition of honoring McKenna. "My father told me that Sergeant McKenna saved his life," Hayes Jr. said. "But it wasn't just my father. It was hundreds of pilots, thousands of family members, generations of people who exist because one mechanic decided that regulations mattered less than lives. That's the legacy we're honoring today." McKenna's garage in Long Beach still operates under different ownership. On the wall in the back office hangs a faded photograph, a young mechanic in grease-stained coveralls standing next to a P-38 Lightning New Guinea, August 1943. Below the photograph is a small brass plaque, "James McKenna, Master Sergeant USAAF, Innovation Saves Lives." The lesson. The story of the piano wire modification matters because it illustrates a fundamental truth about innovation during war. The best solutions often come from unexpected sources. Military organizations are hierarchical by necessity. Decisions flow from officers to enlisted personnel, from headquarters to field units, from engineers to mechanics. This structure works well for routine operations but can be dangerously slow when battlefield conditions demand immediate solutions. McKenna's innovation succeeded because he identified a problem killing pilots, developed a solution using available materials, implemented it without waiting for approval, and proved its effectiveness through results. He violated regulations, falsified maintenance records, and risked court-martial. But he saved lives. In the end, that's what mattered. The broader lesson extends beyond military aviation. In any organization facing urgent problems, the people closest to the problem often see solutions others miss. Listening to those people, empowering them to act, and accepting solutions that violate procedure can mean the difference between success and failure. McKenna never claimed to be innovative or heroic. He insisted he was just a mechanic fixing a problem. But that modesty obscures the courage required to act when action violated every rule. That courage, the willingness to do what's right rather than what's authorized, is the real legacy of the piano wire modification. And it's a lesson worth remembering.